Okay, guys. So when you have a function which you can write in the form y is equal to f of x, as in those are the functions that we were looking at initially. This function is said to be an explicit function, i.e. the x factors and the y factors can be written separately. You can be able to separate the x factors from the y factors so that you're able to write them separately. That's an explicit function. However, if you have a function which has been written in such a way that the x and the y factors are combined such that separating them is kind of hard. Let's say, for example, you have something like y cubed plus 2x squared is equal to y squared minus x. Such a function is called an implicit function. It's been written in such a way that the y factors, like if you want to make y the subject of the formula, it's kind of impossible. You bring this here, but you'll not be able to make y the subject of the formula. So such a function is called an implicit function. And today we want to look at the how to differentiate an implicit function. Now, we said if you're differentiating, let's say a function y is equal to x, the derivative is dy dx is equal to 1. Look at how y is being differentiated. If you're differentiating y, you get dy dx. And if you're differentiating x, you get 1. So since our functions are mixed in such a way that the y's cannot be differentiated from the x, just remember that y is your main function, like y is a function of x. So y is the main. So whenever you're differentiating y, remember there's dy dx. What do I mean by that, guys? Let's say we want to differentiate this function here. What is the derivative of y cubed? If we were to differentiate it normally, algebraically, this is 3y squared. But since y is the main function, whenever y is being differentiated, we've got to have some dy dx. So we'll have dy dx there. Plus, differentiating 2x squared will just give 4x. Is equal to, differentiating y squared will give 2y, but don't forget there's the dy dx. Minus differentiating x will give 1. So in order for you to get your answer for this one, then you can decide to put your dy dx together so that you have dy dx. Bring this to the other side. We will remain with, on this side, minus 4x minus 1. And then all this will be divided by the values that had the dy, 3y squared minus 1. 3y squared minus 1. Basically, what I'm trying to say is that whenever you're carrying out implicit differentiation, when you have the functions written such that you cannot be able to separate the y factors from the x factors, then don't forget that y is the main function, and when you're differentiating it, there's the dy dx. Let's look at another example. Let's say you're told to differentiate. So differentiate the following functions. X squared plus y squared is equal to 25. So how do you go about differentiating this function? The derivative of x squared is 2x plus, the one for y is 2y, but don't forget there's dy dx, and the derivative of 25 is 0. So what is your dy dx? Make dy dx the subject of the formula. Dy dx is equal to, bring this to the other side, this will be minus 2x, all this divided by 2y. So that and that, you remain with minus x over y. Okay, so basically that's how you carry out implicit differentiation, guy. Whenever you're given functions which have just been joined, let's take up another example. Let's say you have 2y squared minus 5x raised to power 4 minus 2 minus 7y cubed is equal to 0. You're told to differentiate that. So how do you go about differentiating that? How do you go about differentiating that? So differentiating this first term, 2y squared will give us 4y dy dx minus differentiating 5x raised to power 4 will give 20x cubed minus differentiating 2 will get 0 minus differentiating 7y cubed will give 21y squared. The derivative of 0 is 0. So you can make dy dx the subject, and sorry, there's dy dx here because this was y, dy dx. So put the terms with dy dx together. So we have 4y minus 21y squared is equal to, take this other terms the other side. So I have 20x cubed. Make dy dx the subject of the formula, and this gives 20x cubed. All this divided by 4y minus 21y squared. And that is the answer. So that's how you go about differentiating these functions, guys. I hope that's clear. Where you see the y, don't forget that you're differentiating and there's the dy dx. I hope you guys had already written that. I hope I've not cut you short. So one last example for that one. I want us to look at one last example for that one. Okay, so let's say you're given 4y raised to power 5 plus 6x raised to power 7 minus 6y is equal to 4. And then you're being told to differentiate this. So the procedure is the same. Differentiating 4y raised to power 5 will give 20y raised to power 4 plus differentiating, and there's the dy dx. Differentiating 6x raised to power 7 will give 6 times 7, and then x raised to power 6 minus differentiating 6y will give 6 dy dx. Where there's y, don't forget to put the dy dx is equal to 0. So you can bring the dy dx's together, factor out dy dx, then you have 20y raised to power 4 minus 6. And then the values that don't have dy dx, you can take them to the other side. So we have 6 times 7 on this other side. So minus 6 times 7, x raised to power 6. So if you want dy dx, your dy dx will be equal to minus 6 times 7, x raised to power 6, all this divided by 20y raised to power 4 minus 6. So basically that's it, guys, for implicit differentiation. So that's it. That's how you go about differentiating implicit functions. Now, what if you're given, I want to go on to the next session. What if you're given containing products or quotients? How do you go about implicit functions that contain products or quotients? So let's write differentiating implicit functions containing products and quotients. So differentiating implicit functions containing products and quotients. How do we go about differentiating such functions, guys? How do we go about differentiating such functions? So let's say you're given a function like x, y squared, and then you're being told to differentiate this function. How do you go about differentiating this function? Now, guys, as you can see, we have this. We will take this as two different functions. Let this one be your u, and let this one be your v. Using product rule, we will evaluate u prime v plus v prime u. Okay, let's go. So what is that going to give? What is u prime? If you differentiate x, you get 1 multiplied with v, which is y squared. Plus, if you differentiate v to get v prime, you get 2y dy dx multiplied with u, which is x. So our answer becomes y squared plus 2yx dy dx. That is, you've been given both of them. You're being told use implicit differentiation, and you've been given both of them joined together as a product. That's how you go about differentiating that. Let's say you have them given as a quotient. So this is example 1. Example 2, let's say you're given x squared over y squared, and then you're being told to differentiate. So let this be your u, let this be your v. Since it's a quotient, we will use quotient rule. All this divided by v squared. Okay, if u is x squared, guys, what is our u prime? Our u prime is 2x. We multiply with v. V is y squared minus, what is our v prime? If you differentiate y squared, you get 2y dy dx. Don't forget the dy dx multiplied by u, and our u is x squared. And all this is divided by v squared, and our v squared is y raised to power 4. And basically that becomes our answer, guys. So note that when you're differentiating, this is what you get. I hope that's clear. I hope that's clear, guys. Let's take up 2 last examples on differentiating implicit functions containing products and quotients. I want to take up 2 last examples, so I will be closing this one. Okay. So let's say you're given, you're told to find d dx over 2x cubed y squared. D dx basically means differentiate or find the derivative with respect to x. So guys, this is a product, and we will let this here be our u, and then let this be our v. So basically, if that is the case, we are using product rule, u prime v plus v prime u. Okay, if u is 2x cubed, what is our u prime? U prime will be 6x squared multiplied with v, which is y squared, plus v prime. If you differentiate y squared, you get 2y dy dx. Don't forget that. And then we have u, which is 2x cubed. So basically this right here is our answer for that particular derivative. And finally, you're being told to get d dx over 3y over 2x. So how do you go about this? Now, this is a product, so we will use the quotient rule. We have both x and y. We will let this be u, and we will let this be v. So the formula is u prime v minus v prime u, all this divided by v squared. Okay, let's go. What is u prime? If you differentiate 3y, you will get 3 dy dx. Multiply with v, which is 2x, minus v prime. Differentiating 2x, you get 2. Multiply with u, which is 3y. All this divided by v squared. And our v squared is 2x squared. So you can go ahead and simplify that. That is the answer, guys. So that's it on implicit differentiation. I would like you guys to do exercise 131. 131. And see if you can be able to do those questions right. And also exercise 132. Just do these exercises for practice. You can do as many questions as possible just to try and see if you're able to get the flow of this implicit differentiation. Okay, guys. So the next thing I want us to look at is logarithmic differentiation. Now, in order for you to carry out logarithmic differentiation, I'm assuming you guys already know the basic laws of logarithms because they are going to be very useful. So maybe if you don't know, I can just write the basic 3 laws. So logarithmic differentiation. I don't know if the person who's calling me is from this class, because I am not able to pick the calls as we are having a session, because I can see so many people trying to call. So if it's from this class, kindly just text your class rep to tell me, Ama, you can tell someone so that you write it in the chat. I'm not able to pick the calls, guys. So logarithmic differentiation. Now, you are supposed to know the laws, at least the basic laws of logarithms. Now, logarithmic differentiation, basically, most of the time, it's used to differentiate expressions. You find that you will be given expressions which have been written in such a way that if you are to just differentiate them using the laws, you will end up using product rule, quotient rule, combined with chain. Like, it will probably be so tedious. So if you're given expressions which look so tedious differentiation, then think of introducing logs so that you use logarithmic differentiation for those expressions. Okay, so these are the like basic laws of logarithms. I hope you guys can be able to remember. So as I've said, logarithmic differentiation we use to differentiate expressions. Now recall, I told you guys, if you're looking for d dx of ln x, i.e. if you're differentiating ln x, it is given by 1 over x. And generally, if you're looking for d dx of ln f of x, any logarithmic function, if you're told to differentiate, it will be given by you writing the f of x in the denominator, and then in the numerator, finding its derivative. So for example, if I tell you get the d dx of let's say x squared plus 2, sorry, ln x squared plus 2. This will be the same as writing x squared plus 2 in the denominator, and then up here writing its derivative. So if you differentiate x squared plus 2, you get 2x plus 0, which is just 2x. So this is how you differentiate a logarithmic function, guys. So if you already have this and you already have the laws, let's look at some expressions here and apply the laws of logarithms in differentiating them. So expression number 1, let's say you're given something like x plus 1 and then x minus 2 cubed. You're told to find d dx of this. Now, guys, as you can see, we have two expressions here. So if we are to just multiply this directly, probably we would have to use product rule, then chain rule, because this is inside this. So it will be very tedious. So the best thing to do whenever we have such expressions, like, let me write it nicely. Let's say y is equal to this. So y is equal to this, and then you're being told to get dy dx. So for this expression, the best thing to do when you're solving is to introduce logs to both sides so that you can be able to break this one down using the laws of logarithms. So I will introduce log to base e, which is ln e to both sides, ln x plus 1, x minus 2 cubed. Now, using the addition multiplication law of logarithms, if you have two which have been joined together by addition under the log, it's the same as separating them by addition. So I will have ln y, this is equal to ln x plus 1 plus ln x minus 2 cubed. But you know that this cubed here is the same as me writing a 3 there. Then I can now go ahead and differentiate, because now I've already simplified. Now remember how to differentiate a logarithmic function. The derivative of ln y is 1 over y. However, don't forget under implicit differentiation, what did we say? If you're differentiating y, there's got to be the dy dx besides it. What is the derivative of ln x plus 1? You come and write x plus 1 down here. Then you find the derivative of x plus 1 and write it on top. If you differentiate x, you get 1. If you differentiate 1, you get 0. So we will have 1 there. Plus 3. What is the derivative of ln x minus 2? So you come and write x minus 2 in the denominator here, then you find its derivative up here. If you differentiate x, you get 1. If you differentiate 2, you get 0. So that's it. guys. So what's going to be our answer? Remember what we were looking for was for the derivative. So we were looking for the dy dx. So make dy dx the subject of the formula. We will have 1 over x plus 1 plus 3 over x minus 2. All this multiplied by y. We will remove this 1 over y on this side, bring it to this other side. It's the same as multiply by y, multiply by y. So this is our answer. Dy dx is equal to 1 over x plus 1 plus 3 over x minus 2 multiplied with y. But what was our y? Y was the first expression that we were given, which is x plus 1, x minus 2 cubed. So that's it, guys. This now becomes our answer. You see, it's very easy. If we were to do this using product rule, then chain rule, it would have been very tedious. So whenever you have such expressions, then it is wise that you introduce ln on both sides so that you're able to differentiate easily. Okay, guys, so finish writing that. I want to look at another example under logarithmic differentiation. I hope you've already finished copying. Birgen, have you finished writing that? Birgen? Okay, I can see Alex. Alex Ngui, have you finished writing that? Okay, guys, so next example. Example number 2, you're given y is equal to x minus 2 cubed, all this divided by x plus 1 squared 2x minus 1. And you're told to differentiate. So clearly, as you can see, this thing all here, it involves multiplication, division, and there's also, if you were to differentiate, you'd probably use some chain rule. So I want to write this in power form. This is the same as y is equal to x minus 2. This is the same as raised to the power 3 over 2. 3 over 2. Okay, so okay, 3 over 2. So I don't know where that line has come from. Is it erasable? Really, I'm not able to erase it. Okay, fine, 3 over 2. And then this right here, I can be able to write it as x plus 1 squared 2x minus 1. Introducing logs to both sides, guys, I'll have ln y is equal to ln the whole of this side. Now I want to break that down. Ln y is equal to, now if you're having log, this two have been joined together by multiplication, and this by division. So I'll have ln, what is on top, which is x minus 2, 3 over 2, and then minus ln x plus 1 squared plus, because those two have been joined together by multiplication, ln 2x minus 1. So finally, opening this bracket with minus, that will give me ln y is equal to ln. So I can have this 3 over 2 here using the laws of logarithm, x minus 2 minus, bringing this 2 here, 2 ln x plus 1 minus, so we have like 10 minutes to go, guys, minus ln 2x minus 1. So let's differentiate that. Differentiating ln y, what do we get? The derivative of ln y is 1 over y dy dx. And this is equal to 3 over 2. Differentiating ln x minus 2, you write x minus 2 down here. And then up here, you come and write the derivative of what you've written down here. So if you differentiate x minus 2, you get 1. Minus 2, differentiating ln x plus 1. So you come and write x plus 1 down here and then on top you write the derivative of x plus 1. So if you differentiate x plus 1, you get 1. Minus, if you're differentiating ln 2x minus 1, so you come and write 2x minus 1 here. Then on top here, you write the derivative of what you've written down. So derivative of 2x minus 1 is 2. So this is basically our answer, guys. We just make dy dx the subject of the formula. So dy dx is equal to dy dx is equal to, so this is the same as 3 over 2 x minus 2 minus 2 over x plus 1 minus 2 over 2x minus 1 multiplied with y. But what is the value of our y? Here is our y here. So our y was root x minus 2 cubed, all this divided by x plus 1 squared 2x minus 1. So that's it, guys, for logarithmic differentiation. That's exactly how you go about it, guys. So on this right here, I would want you guys to do exercise 133 for practice. Exercise 133. Do as many questions as you can. The answers are already there in the questions. Try and see if you can be able to get the answers. If not, then let me know the ones you are unable to do so that we can do them together. I can do them for you. Now, guys, we also use logarithmic differentiation to differentiate functions of the form. So I want to close this section here. I hope you've already written. So differentiation, so differentiation of f of x raised to power x. Let's take up an example. Let's say you're told y is equal to x raised to power x, and then you're being told to differentiate. So when you have functions written like this, raised to power x, there's the variable, and then the variable is also raised to the power of another variable. The best way is to differentiate using logarithmic differentiation. So I'm going to introduce logs to both sides. So I'll have ln y is equal to ln x raised to power x. This is the same as ln y is equal to, using the power law of logs, x ln x. Now, guys, I use, this is an algebraic function. This is a logarithmic function. So I will use the product rule to differentiate. So I will let this one be u and let this one be v. And remember product rule, u prime v plus v prime u. Okay, so what does that give? Differentiating ln y, we get 1 over y dy dx. And then differentiating on this other side, we're going to use product rule. So u prime is 1 multiplied by v, which is ln x, plus v prime. If you differentiate ln x, you get 1 over x, multiplied with u, which is x. So what is my dy dx? dy dx is equal to ln x plus this x, and this x cancel, so we get 1 there. All this multiplied with y. But what is y? Y was initially given as x raised to power x. So whenever you have functions written in the form f of x raised to power x, the function is a variable and it has also been written to the power of another variable, then the best way to differentiate is by introducing logs or just using logarithmic differentiation. We have like 5 minutes left, 4 actually. So I want to do one last example for this one, guys, before this session ends. Okay, so example number 2 for that one. Let's say you're told y is equal to x to x. So how do we differentiate that? We introduce logs to both sides. So I will have ln y is equal to ln x to x. Using the laws of logarithm, the power law, I can write this as 2x ln x is equal to ln y. Then I go ahead and differentiate. Differentiating ln y, I get 1 over y dy dx is equal to, here I will use product rule. So let this be u, let this be v. Then the rule is u prime v plus v prime u. So u prime, if you differentiate 2x, you get 2 multiplied by v, which is ln x, plus v prime. If you differentiate ln x, you get 1 over x multiplied with u, which is 2x. So making dy dx the subject of the formula, we will have dy dx is equal to 2 ln x. The x will cancel with the x, so I will remain with plus 2. And then all this is multiplied with y. You cross multiply the y on both sides. So multiply with y. But what is y? Y is x to x. Guys, y is x to x. Okay. So that's it, guys, for functions of that form. So for practice, you can look at exercise 134. Please, all these exercises need to be done. The least amount of questions you can do is at least 3. But if you feel like you're still not getting the answers, you can do as many as possible so that you're able to see if you're getting them. And if you can still not get them after doing the exercise, please reach out. Let me know. So guys, that's going to be the end of this first session right here. Please don't leave. Allow me